And welcome back. As we continue our cosmic journey, let's go ahead and focus in on the Earth by talking about the seasons. Let's start first off by addressing a common misconception. Many people believe that our seasons are brought about by the position of the Earth and the Sun. If you recall, we had talked about how Earth has an elliptical orbit, and so many people think that on the elliptical orbit, when we are, of course, farther away, that's going to be different than we are closer to the Sun. So the thinking is, well, if the Earth is closer to the Sun, we have to be warmer. And if we're farther away from the Sun, we have to be colder. While this does seem like a very plausible explanation, it's actually not correct. The Earth's elliptical orbit varies only by about 3%, which is not enough to really trigger the seasons. Earth is actually closer to the Sun also in January. But for those of us in the Northern Hemisphere, we're experiencing winter. Which doesn't make sense if we're closer, we should be warmer, but of course, again, in the north, we are experiencing winter. Now, each hemisphere, north and south, also is at the same time experiencing opposite seasons. So, what instead is more responsible for our seasons is that 23.5 degree tilt of the Earth's axis. So, let's talk about the seasons and sunshine. So in this image at right, you can see Earth enters different seasons as it circles the Sun. In June, for example, the Northern Hemisphere kind of leans more into the Sun, and those in the North experience summer and have longer days. In December, during winter in the Northern Hemisphere, the Southern Hemisphere has now switched to lean more into the Sun and is illuminated much more directly. And then in spring and autumn, the two hemispheres are receiving much more equal shares of sunlight. So again, if we look here in our December 21st, we have our winter solstice, and we can see right now what hemisphere is seeing more sunlight? The south. If we look at the summer solstice, June 21st, we can see the northern hemisphere is leaning more into the sun. Whereas if we are looking at the two equinoxes, we can see again we have the equal shares of sunlight. Now, we talked about shares of sunlight, but what does it actually mean? Well, if we look at the sun's rays in summer versus winter, it can give us a really good comparison of what this means. So how does the sun favoring one hemisphere translate into making it warmer for us down here on the surface of the Earth? Well, in the summer, the sun appears high in the sky, and its rays are actually hitting Earth much more directly, spreading out less. And we can see that here in image A. Those 5 rays of sunlight that are here in this image are very much more concentrated. It's coming in at about 1 meter squared, and you can see that when it hits the Earth, it's about 1.04 meters squared. So they're pretty concentrated, and the more concentrated light is, the warmer and more radiant it will be. Now, in wintertime, the sun is much lower in the sky, and its rays spread out over a much wider area, becoming less effective at heating the ground. And again, if we look at image B here, we can see we have that same 5 rays at 1 meter squared, which are now spreading out to 2.24 meters squared, which means because they're more spread out, they can't radiate that ground with the same amount of energy. Now, the sun's path in the sky for different seasons can mean different things depending on which hemisphere you're in. So the second effect, beside the concentration of sunlight, has to do with the length of time our sun is spending above the horizon. Now, on June 21st, the sun rises north of east and sets north of west. So that means for observers in the northern hemisphere of Earth, the sun is spending about 15 hours above the horizon in the United States, which means we get more daylight. On December 21st, the sun rises south of east and then sets south of west. It spends about 9 hours above the horizon in the United States, which means we have fewer hours of daylight and more hours of night. And then, of course, on March 21st and September 21st, the sun spends equal amounts of time above and below the horizon in both hemispheres. And again, if we look at this observation here, we can see we have our celestial equator. Here's our observer. Here's our north celestial pole. And you can see the sun's path is currently here for June 21st. This is when we're getting our maximum. And you can see where that is positioned here. So this is why we receive, of course, more daylight, because we are above that celestial equator. When we move to the equinoxes, you can see the sun's path is right along the celestial equator, which again means we are getting equal amounts of sunlight. And it has now fallen below the equator on December 21st, which means we now have the fewest hours of sunlight. So let's look at that with a little more detail, starting with Earth on June 21st. What does that mean for the different pieces of Earth? Well, the date of the summer solstice, again June 21st, in the northern hemisphere is when the sun shines down most directly. So again, if we think about those images of light coming straight down, that is the light when it's most concentrated. Now note, as the Earth turns on its axis, the North Pole is in constant sunlight, while the South Pole is veiled in 24 hours darkness. And we can see that right here on June 21st. And right here you can see that where that is, there's no way that position is not going to be in the sun. And same thing here, the South Pole, you can see it's always here in the shadowed half. Now the sun in this current time is at the zenith for observers on the Tropic of Cancer, which means this is the 90-degree mark where sunlight is coming in the most directly. Now if we flip that to December 21st, it's pretty much taking everything we just talked about and making it the opposite, because this is the date of the winter solstice in the northern hemisphere, which means that the North Pole is now in darkness for 24 hours, and our South Pole is now the one that is illuminated. The sun is now at the zenith for observers at the Tropic of Capricorn, which means you can see it's now hitting directly on right here, and thus is low in the sky for residents of the northern hemisphere, which is why this is our shortest day. Now, of course, we talked about the two extremes. We have, the solstices, but what about the equinoxes? Well, halfway between our solstices, on March 21st and September 21st, the sun is on the celestial equator, as we already mentioned. From Earth, what happens at those equinox dates is it appears that our planet, the sun itself, is appearing above the planet's equator and is favoring neither the north nor the south hemisphere. So every place on Earth receives roughly about 12 hours of sunshine and about 12 hours of night. Now the points where the sun crosses the celestial equator at that time is called the vernal or spring and the autumnal or fall equinoxes. Now, we've, of course, up to this point have really discussed this very well with the extremes. We talked about the equator, we've talked about the north and south hemisphere, we've talked about the poles, but not everybody lives at those locations, and so we have different latitudes. So what does that mean for those different seasons? Well, the seasonal effects are different at different latitudes of Earth. So for example, if we are at the equator, not the celestial equator, but the actual equator on Earth, one thing you'll notice is that the seasons are pretty much the same. Every day of the year, the sun is up about half the time, so there are approximately about 12 hours of sunshine and about 12 hours a night. And local residents who live near that zone tend to define the seasons not by the 4 seasons that we're very familiar with, but instead by the amount of rain they receive. So they typically have things like a wet season and a dry season, rather than using the amount of sunlight to define the seasons. Now, as we travel further to the north or to the south of the equator, we're going to find that the seasons become much more pronounced until we reach the extreme cases in the Arctic or Antarctic. So, for example, at the North Pole, all celestial objects that are north of the celestial equator are always above the horizon, and as Earth turns, they're going to circle around parallel to it. So the sun is north of the celestial equator from about March 21st to September 21st. So at the North Pole, the sun rises when it reaches the vernal equinox and sets when it reaches the autumnal equinox. And so therefore, each year, there are about 6 months of sunshine at each pole, followed by about 6 months of darkness.